So we are now at graphs 3. And what I will explain is how to conduct some further analysis, how to look at the gradient of your linear graph, and find the plus and minus uncertainty for that gradient value. Now, in order to do that, you must plot your error bars first. You can see them on here. Again, this depends on the experiment, because you might find that once you do your L to the power of half, and once you process your uncertainties, you multiply them by that half, you might find that it's really, really hard to plot them. And if that's the case, if it's actually too hard to find that half interval, then you can't really do this exercise. So we're going to use this diagram, which has some exaggerated uncertainties. First, draw your error bars. Using the scale on your x and y axis, you measure out the uncertainty value, plus and minus, whatever it might be, and you place it on either side of your point. Just like when you do error analysis, you have to do some calculating, some processing first, and then you work out your uncertainties. This is no different. To find the uncertainty in a graph gradient, for example, you first need to work out your gradient. So that's the first thing that you have to do, and I'm going to do that now. Now, it's actually really, really hard to do this with this particular software, but remember that gradients are rise over run, so your delta y over your delta x. When you're doing this for your graphs, please show your read-offs, so actually show the points that you're measuring from the graph so we can see what you're thinking. So what we can see here is that our read-offs show that we're starting here about 42.5 to 32, 42.5, 32. That's our y increment, minus 10, and this little section here, 0.5, which gives us an increment of 9.5. So if we divide the change in y by the change in x, that will give us 1.1. That's our gradient. So that is our actual value. And now we're going to try and find our maximum and minimum gradients. Now let's think about our pluses and minuses. What is the maximum? Let's think of the plus. What is the maximum possible range of mistake that we can possibly make? So that means if we look at our gradient, our range of error is marked by our error bars. So our maximum possible mistake has to be within that error bar region, okay? The best way to do this is to find the general trend. And if you can identify the top of the error bar of the last point and the bottom error bar of the first point, that should give us our approximate steepest possible line. Okay, so generally that is the convention. So how do you plot the steepest possible gradient within our margin of error? You take the maximum uncertainty of the last reading and the minimum uncertainty of the first reading, and you join them up. However, a word of caution, your line must go through all the error bars. So it must fall within the margin of error. If that doesn't happen, you need to kind of consider maybe the next one. In this particular graph, if we'd plotted using this point here, then the line would have been outside the range of this one. So it's not fair, because our error lines, our steepest gradient, must be within a realm of error of all the rest. So what we're doing is we're taking this one. Ultimately, all your lines of best fit and your maximum and minimum gradients must fall within the error bars. So There is a general rule, but you do have to be careful with it. In this case, the second to first, or the second point, is the one that's been used along with the last one, because by drawing the steepest possible line, it falls within the error bars of all the points. Okay, so now we have this steepest possible line. We now need to work out the gradient of that steepest possible line. Again, not the easiest thing to do with this program, but you can kind of see that it's 43. We're going to do the y-axis interval. 43 minus 31. And now 10, approximately 10. So now this gives us our upper bound value. So our margin of error allows the gradient now to be 1.1 up to a maximum of 1.2. Now let's see what our minimum possible gradient might be. And for that we have to do exactly the same thing, but not look at the steepest possible line. We now need to look at the least line, which still falls within our uncertainty. And you can see it here. The way that it's been plotted is, again, the first point, the maximum uncertainty point has been found. And on the last one, again, the last one isn't quite right, because if we were to use this point here, our line would fall outside of all the others. So that's not acceptable. But this one is better. So the second to last one. So we've got this top line here, goes through all the error bars to this point. So now if we try and work out the gradient there, let's try this point more or less, to approximately there. Oops, very difficult to draw a straight line. So this time we have a y-intercept of 42 minus 33, and our x-interval is 10.5 minus, well, it goes all the way up to here, almost 0. So this will give us 0.86. So we now have a range of 1.2 at the top, and the lowest possible gradient we can have is 0.86. So we're almost there. We now know our value of our gradient, and we know how big it could possibly be within our range of error, and we know how small it could be. So now we just need to write that as an uncertainty. So here are our two values again, and first we're going to round this up, because as you can see from our actual reading, we've got one decimal place, so we don't need 2 here, we need 1. And let's have a look at the value 1.1. What is the difference between 1.1 and 1.2? Well, it's 0.1. Okay, so that's our upper bound range. And then in the opposite direction, what is the difference between 1.1 and 0.9? We've got 0.2. So we have a slightly different margin of error between the minus and the plus. So what we do is we take the biggest one as our uncertainty. So the actual reading now is, after all of this, the actual gradient value is 1.1, but it's plus or minus 0.2, because that gives us our maximum possible deviation from the gradient to the maximum and minimum gradients. I hope that's made sense. And to show that on the graph again, we can see that it's 1.1 in the middle, plus or minus 0.2 as a margin of error. So that's your final uncertainty for any gradient value.